Alright, so this is the Quidio Chapter 1 and 2 AP question. Alright, so starting off, read the question. Two parents trying to build catapults with and trying to get it which one will give you the best odds of hitting those 5 centimeters. So comment on any similarities and any differences in the two distributions. And then you have to maximize the probability of having ping pong balls land within the band. So which catapult of the two would be better, and then justify. Using the catapult that you chose in part B, how many centimeters from the target should this catapult be placed, and explain. Alright, so starting off, we have to comment on any similarities and differences basically within it. So we need to find our SOCS of this graph. No, not this SOCS. Shape, outlier, center, spread, SOCS. So I'm going to actually get rid of that. So let's go over to the second page here, where we have our SOCS listed out already. So what we're looking for is similarities and differences in the two distributions by the ping pong balls launched by the catapults. I'm going to draw the two dot plots as box plots below so you can get a better representation of what the data looks like. So catapult A has a minimum of 122, a quartile 1 of 133.5, 136 as the median, quartile 3 starts at 138, and the max is 155. And the thing is, since this graph is a little skewed to the right, I'm going to use a modified box plot instead to show you how it's skewed and has outliers using the 1.5 IQR rule. So when I times these four values times 1.5, they did not fit within the inner quartile range, so they are excluded. So quartile 1 and quartile 4 are smaller. As you can see, the four outliers, 3 of them being on the right. So after I draw catapult B's graph, you can see that it has an approximately normal shape and a smaller spread of data than catapult A. It even has no outliers, but catapult A has 4, 3 on the right side. So that covers shape and outliers. When we get to center, which is about the median, they have approximately the same median at 136 and 138, which is fairly close considering the centimeters away they are in general. And then when we get to the spread, which is a 5-number summary, catapult A has a larger range. It also has a larger inner quartile range of 4.5 than catapult B at an inner quartile range of 3. The minimum for catapult A is 122, quartile 1 133.5, median 136, quartile 3 at 138, and max at 155, compared to catapult B that has a minimum of 133, quartile 1 of 137, a median of 138, a quartile 3 of 140, and a maximum of 144. It's more consistent. Catapult B is more consistent than catapult A. So I would choose that personally. When we look at question B, when we want to maximize probability, you would want to choose catapult B since it has a smaller spread of data. It has an inner quartile range of 3, so you would actually want the more than 50% of the data to land within that 3 centimeter difference, where the target line is a 5 centimeter band. So you would want that compared to catapult A, which actually has a larger inner quartile range. And then using the catapult in part B, how many centimeters from the target line should it be? I said catapult B should be 138 centimeters away, since that would be the appropriate length for the most data taken would land. When I went back and counted, 30 out of the 40 ping pong balls landed between that 5 centimeter gap between 136 and 140 centimeters away. So that was the best choice in my opinion, where only 21 landed on catapult A's range of 5 centimeters. So overall, I would say catapult A has the larger spread, catapult B has a smaller spread, and catapult B is the better choice to use for this